In this video, I will show how to build a small constraint programming solver that we will use to model and to solve the NQueens problem. The way I will introduce it is first, I will show the high-level NQueens model inside this TinyCSP solver, and we will call that the TinyCSP model for the NQueens problem. So that's the source code to solve the NQueens problem with TinyCSP. So you can really put that source code as it is inside the main method. So as you can see, first I've got the number of queens. So in that case, let's say that I want to solve the problem for 10 queens. I create a small CSP object. That will be really an instantiation of your library, and this library will make it will really make it possible to solve the NQueens problem in a high-level way, in a declarative way. So then I create the variables, and so I will create n variables for each of the queens. And as you know, when I declare an array of variables in Java, it's initialized as an array of null references. So I need to instantiate every single element. So I create a variable n. Okay, so I declare the variables there. And then I've got all the constraints of my problem. I will come back to that later, but as you can already imagine, this is where I'm posting the constraint. We say posting the constraint to the model, or declaring or adding the constraint to your model. So we will really add each of the constraints, and it will be not equal constraint. We will really add them to the CSP solver, to the instance of the CSP solver. Then we have the array of solutions as we had before, and we will be notified using this lambda or this closure, which is a consumer again. We will be notified every time a feasible solution is found, which means a solution that satisfies all these constraints. And so it's quite clear already that we separate the variable declarations and then the constraints, and then we have the search. So for the NQueens problem, let's give a little bit more details. So n, clearly the first value for n, so that one, represents the number of decision variables. Okay, and then you've got another n here, and that one is for all the possible values that you will have for all the queens. We call that the domain of the variables. The domain is the range of possible values for every variable. Okay, so every variable I has a domain of n, which means that the domain is all the values from 0 until n-1. Okay, the n is not included there. So that's the domain of every variable for every queen. Then we have the constraints declaration. The first constraint that we have is that no two queens can be on the same column, as you know already, because we have one decision variable, let's say q of I, for every queen. We know that this one will be always satisfied, because if we assign every decision variables to a single value, that should be part of the domain, of course, then we know that there is no possibility to have two queens on the same column. On the same row, we need to state that one. And so we will add the constraint or post the constraint to the CSP object. We will say that for every pair of indices, I and j, that are different, we say that they should not be equal. So that's really the constraint that q of I should be different from q of j. Okay. Then we have the one that states that they cannot be on the same left diagonal, and so we say that qi is different from qj plus some value that is equal to I minus j. That's for the left diagonal. And I also need to add the constraint to the model to say that I want to prevent two queens to be on the same right diagonal. So that's this constraint that is represented here in red. And that's it. We have a very nice model for the NQueens problem. As you say, all what we did is just to declare the variables, the domains, and the constraints. In the next video, we will explain the computation that can take place inside the TinyCSP and how all these modeling objects are implemented in practice.